What if you could process 1 billion numbers without crashing Python? No memory error. No freeze. Aston. I am Ahaz. Today in episode 16, Iterators and Generators, you will learn the most memory-efficient pattern in Python. Generators produce values one at a time, on demand, using almost zero memory. They power Django query sets, pandas pipelines, and every large-scale data system. Let's go. First, the problem that generators solve. You have a file with 1 billion log lines. If you load the whole file into a list, you need 8 gigabytes of RAM. Your computer crashes. With a generator, you load exactly one line at a time. You use 200 bytes of RAM total. Same result. 0 crashes. Watch this memory bar. The list fills all available memory at once. The generator uses a flat line, nearly nothing. This is the difference between amateur and professional data code. Before generators, you need to understand iterators. Every for loop in Python uses an iterator behind the scenes. Call iter on a list. You get an iterator object. Call next on that iterator. You get the first item. Call next again, second item. Call next past the end. Python raises StopIteration. The for loop calls iter and next automatically. You never see it. Strings, lists, tuples, dictionaries, files, all of these are iterable. Any object that has a _iter method is iterable. Any object that has a _next method is an iterator. That is the entire Iterator Protocol. The yield keyword is what makes a generator. A regular function runs completely and returns one value. A generator function runs, hits yield, pauses, hands back a value, and waits. When you call next again, it resumes from exactly where it paused. Watch the execution flow diagram. Function starts, runs to yield, value comes out. Execution is frozen. Next is called execution resumes, runs to next yield. This pause and resume is the magic. The function remembers its entire state between calls. Local variables, the position in the loop, all preserved. No regular function can do this. Generator expressions are the fastest way to write a generator. They look exactly like list comprehensions, but with round brackets instead of square brackets. List comprehension with square brackets creates all million numbers in RAM right now. Generator expression with round brackets creates nothing yet. Values are produced one at a time only when you ask for them. This is called lazy evaluation. The generator is like a recipe. The list is like cooking all the food and storing it. If you only need the first 10 items, the generator only computes 10. The list computes all 1 million. Lazy is not slow. Lazy is smart. Generators can be infinite. Lists cannot. This counter generator runs forever. It starts at 0 and yields the next number on every call. There is no end. If you try to make an infinite list, Python would crash immediately. A generator uses constant memory regardless of how many values it produces. Watch the counter scroll, 1, 2, 3, going on forever. The ilist function from Iterators lets you take exactly what you need. Ilist of counter and 10 gives you the first 10 numbers and stops. The generator produces only 10 values and pauses forever. This pattern powers every streaming data system. Log processors, sensor readers, stock price feeds. Our mini project, a CSV log file processor using generators. 3 generator functions chained together like a pipeline. Readlines generator opens the file and yields one line at a time. Parselines generator takes lines and yields parsed dictionaries. Filter errors generator filters only lines where level equals error. We chain them. Each feeds the next. None of them load the whole file. The entire pipeline uses constant memory, even for a 10 gigabyte log file. This is how Pandas, Spark, and every big data tool works internally. Small composable generators chained into powerful pipelines. Your challenge for today: build a Fibonacci generator. Step 1. Write a generator function called Fibonacci. Step 2. It should yield the Fibonacci sequence forever. 0, 1, 1, 2, 3, 5, 8, 13, going on infinitely. Step 3. Use ilist to get the first 20 Fibonacci numbers. Step 4. Write a second generator called Fibonacci square that yields the square of each Fibonacci number. Step 5. Find a first Fibonacci number greater than 1000 using next and a generator expression with a condition. Paste your complete code in the comments. I check every single one and reply. Let's recap episode 16. Iterator. Any object with _iter and _next. For loop, calls iter and next automatically behind the scenes. Yield, pauses a function and hands back a value. Generator function, a function that uses yield. Generator expression, round brackets instead of square brackets. Lazy evaluation, compute only what you need when you need it. Infinite generators, constant memory regardless of size. Generator pipeline, chain generators for zero memory data processing. Mini project, CSV log file processor using 3 chain generators. You now write Python that can handle any size of data. Tomorrow, episode 17, Decorators. The most elegant Python pattern. Iterators and generators. Mastered. Your Python can now process unlimited data with zero memory waste. Subscribe. A new episode every single day. Drop your Fibonacci generator in the comments. See you in episode 17 tomorrow.